Our planet is a dynamic and ever-changing place. Beneath its surface, a fiery underworld churns, occasionally reminding us of its raw power. Volcanoes, with their awe-inspiring eruptions, are a testament to this hidden energy. But among these fiery mountains, a select few stand apart: supervolcanoes. These colossal giants possess the power to unleash eruptions thousands of times larger than anything witnessed in modern history. Their eruptions are capable of shaping landscapes, altering climates, and even threatening the very fabric of civilization. Supervolcanoes are not your typical cone-shaped mountains. Instead, they form massive depressions in the Earth's crust known as calderas. These calderas are formed by the collapse of the land surface following a colossal eruption. Unlike conventional volcanoes which erupt from a central vent, supervolcanoes erupt from massive underground reservoirs of molten rock, known as magma chambers. The immense pressure within these chambers builds over time, eventually culminating in a catastrophic release of energy. The threat posed by supervolcanoes is very real. Scientists estimate that a supervolcanic eruption occurs on average once every 100,000 years. While this may seem infrequent on a human timescale, the potential consequences of such an event are too great to ignore. The eruption of a supervolcano would have devastating global consequences, triggering widespread volcanic winters, disrupting agriculture, and potentially leading to societal collapse. Today, scientists around the world are closely monitoring these sleeping giants, working tirelessly to understand their behavior and predict their next move. From the geysers of Yellowstone to the smoldering craters of Campi Flegrei, the Earth is alive with activity, reminding us of the immense power that lies beneath our feet. In the following sections, we will delve into the science behind these slumbering giants, exploring their history, their potential impact, and the ongoing efforts to unravel their mysteries. Nestled beneath the breathtaking beauty of Yellowstone National Park lies a slumbering giant, the Yellowstone supervolcano. This immense volcanic system, stretching for over 30 miles beneath the park, is a constant reminder of the Earth's raw power. Yellowstone's last super eruption, a cataclysmic event that occurred 640,000 years ago, ejected over 240 cubic miles of volcanic material into the atmosphere, blanketing much of North America in a thick layer of ash. Today, Yellowstone is a hotbed of volcanic activity, with its iconic geysers, hot springs, and mud pots serving as constant reminders of the intense heat simmering below the surface. Scientists estimate that the Yellowstone supervolcano has experienced 3 major eruptions in the past 2.1 million years, each one leaving an indelible mark on the planet's history. The most recent super eruption, as mentioned earlier, ejected enough ash to bury a city the size of New York under hundreds of feet of volcanic debris. The probability of another super eruption at Yellowstone in the near future is thought to be extremely low. However, the potential consequences of such an event are so significant that scientists continue to closely monitor the volcano's every move. Using a variety of sophisticated instruments, researchers track ground deformation, seismic activity, and changes in heat flow, searching for any signs that might indicate an impending eruption. One of the most concerning aspects of a potential super eruption at Yellowstone is the global impact it would have. The massive amount of ash and gases ejected into the atmosphere would block sunlight, leading to a volcanic winter that could last for years or even decades. This would have devastating effects on agriculture, global temperatures, and human civilization as a whole. Understanding the dynamics of this sleeping giant is crucial for mitigating the risks it poses to our planet and our future. Across the Atlantic, another supervolcano stirs beneath the picturesque landscape of southern Italy. Campi Flegrei, a sprawling volcanic region located west of Naples, is a stark reminder that the Earth's fiery underworld can awaken in the most unexpected of places. Unlike Yellowstone, which is characterized by a single massive caldera, Campi Flegrei is a complex network of craters, calderas, and volcanic vents spread over an area of roughly 47 square miles. This volatile region has been relatively quiet for centuries, with its last major eruption occurring in 1538. However, recent signs of unrest have put scientists on high alert. Ground deformation, increased gas emissions, and a series of small earthquakes have all pointed to a reawakening of this slumbering giant. In recent years, the ground beneath Campi Flegrei has been rising at an alarming rate, indicating a buildup of pressure in the magma chamber below. One of the most concerning aspects of Campi Flegrei is its proximity to a densely populated area. With over 3 million people living within the volcano's potential blast radius, an eruption could have catastrophic consequences. The historical record provides a sobering reminder of the destructive power of this volcanic system. Around 39,000 years ago, Campi Flegrei unleashed a massive eruption that ejected an estimated 200 cubic kilometers of volcanic material into the atmosphere. Scientists believe that this ancient eruption may have had a profound impact on the climate and contributed to the decline of Neanderthals in Europe. Today, researchers are using a variety of techniques to monitor Campi Flegrei's activity, hoping to gain a better understanding of its behavior and provide early warning of a potential eruption. The fate of millions rests on their ability to decipher the warning signs of this slumbering giant. Yellowstone and Campi Flegrei are just two examples of the many supervolcanoes that dot our planet. From the Long Valley caldera in California to Lake Toba in Indonesia, these slumbering giants pose a constant, albeit low-probability threat to our planet and its inhabitants. While the likelihood of a super eruption in our lifetime is slim, the potential consequences are so significant that even a small chance is enough to warrant close attention from the scientific community. Consider, for instance, the relatively recent eruption of Mount Tambora in 1815. While not a super eruption, Tambora's explosive outburst was the largest volcanic eruption in recorded history. The eruption injected so much sulfur dioxide into the stratosphere that it caused a global volcanic winter, leading to the infamous year without a summer in 1816. Crops failed, temperatures plummeted, and widespread famine gripped the northern hemisphere. Now, imagine the consequences of an eruption, hundreds or even thousands of times larger. Super eruptions have the potential to plunge the planet into a volcanic winter that could last for decades, disrupt global food supplies, and trigger mass extinctions. While we have yet to witness such an event in modern history, the geological record provides ample evidence of their devastating power. It is imperative that we continue to study and monitor these volcanic giants, not out of fear, but out of a desire to understand and mitigate the risks they pose to our planet and our civilization. By unraveling the mysteries of these slumbering behemoths, we can hope to be better prepared for the day when one of them awakens from its slumber.